CNC is a category of manufacturing that stands for computer numeric control. A high-speed carving head removes material following a computer-generated path in incremental layers. Since CNC is a subtractive method, your starting material must exceed the volume of your final part's bounding box. You can carve away your block to reveal both standalone volumes and cavities. CNC is also incredibly handy for carving single-layer designs out of sheet material like plywood or acrylic. CNC can carve away most materials, from hardened steel to the softest foams. The tool bits are made of special hardened material designed to cut in every direction. The best materials to be used are ones that have consistent densities. Materials that melt easily or have inconsistent densities are not recommended. There are a couple of different levels and types of CNC. I'll use these planes to demonstrate. 2-axis will only cut along the X and Y axis, with very limited up and down Z-axis adjustment. 3-axis adds another layer of movement and can move along all three axes, X, Y, and Z, more freely but within certain height limits. 3-axis is one of the most common types of CNC and is a great choice for large sheet carving operations. 5-axis combines the technology of 3-axis, but also moves the workpiece in concert with the carving head, enabling more complex geometric volumes. Another type of CNC is CNC lathing. The workpiece rotates along a central axis, while the carving head creates revolved volumes. Once you've modeled a project in the computer, you can use specialized software packages to generate toolpaths. These are the paths the cutting tool will take to make your design a reality. I'll use the Section View tool to demonstrate what these layers could look like. Depending on your layer height, you could do a rough cut, resulting in aggressive stair-stepping, as shown, or take longer to shave much more incremental layers and remove smaller amounts. So while your computer model may look smooth and undulating, you'll still have layer marks. Finally, CNC has some limitations. For example, the size of the carving tool can only be so small, and even with the thinnest spindle head, it can only carve so deep. Your manufacturer will have specific information on how deep they can drill and how thin features can get. Knowing these limits will help save time in the production process. In combination with the consideration of the plastic's ability to flow through the mold, it's considerably harder to get superfine interior sharps. This is another reason why interior fillets are so important. There are some specialized carving bits that could get close to a true sharp, but as you may know, the more difficult it is to make, the more expensive it'll be.